say, for example, the New York metropolitan area or the Washington, D.C. metropolitan area. And so asteroids of that size could cause significant damage.
And tell me about the actual craft itself and how it's built for a mission into space.
So this particular spacecraft is built specifically for this mission. It's actually got a fair amount of mass on it, and it has one instrument. It only carries one piece of payload, and that's this camera that's very, very high resolution imager, very high precision camera that we will use the images and process them on board the spacecraft and use special software called SmartNav that will autonomously navigate the spacecraft so that when it comes towards the spacecraft, towards the asteroid, we will target it and impact at about 15,000 miles per hour.
And this is, of course, the first ever spacecraft to not be guided by humans. This is really revolutionary technology. What does this mean for the mission and for NASA going forward?
So this is a really important mission to test this technique. It's part of our overall planetary defense program, where we want to make sure that we are looking for and identifying potentially hazardous asteroids and comets that are out in our solar system. Once we find them, we characterize them. We want to better understand what they're made of and what their orbits are so that we can better assess and predict if they might be hazardous in the future. And so this is a really important part of that program. We also want to test these techniques to help us better prepare to mitigate or protect ourselves if there were a hazardous asteroid in the future.
For all those movie fans who remember Armageddon, humanity discovers an asteroid the size of Texas just 18 days away. While that, of course, is not a realistic scenario outside of Hollywood, what's the kind of lead time that NASA would need to actually successfully stop an asteroid that's heading toward Earth?
That's a really great question. It actually takes a fair bit of time. We need the time, we need years of observing to detect an asteroid. And then once we've detected one, if we're going to successfully mitigate, we need to be able to get the spacecraft launched, if that's the technique we're going to use. And then this type of technique is going to make a very small change in the orbital period, the velocity or the speed of the asteroid, which if you have years in advance or decades in advance, you can make a very tiny change in its speed. And over time, it'll have a big effect. So what we really want to happen is when the asteroid comes and it crosses over Earth's orbit, we want to be out of the way. We haven't arrived yet, or we've already passed when the asteroid passes through our orbit. So we just don't want to be there at the same time the asteroid arrives.
Makes a lot of sense. We so appreciate you breaking it all down for us. Dr. Lori Glaze, NASA Planetary Science Director, overseeing the DART mission. We appreciate your time.